Video, we're going to talk about a direct method in solving non-homogeneous equation. And in this case, we'll be using the inverse operator. So you're given a non-homogeneous differential equation in the D operator form. The general solution would be y is equal to y sub c plus y sub p, where y sub c is the complementary solution that is obtained from the homogeneous differential equation with constant coefficients. Then your y sub p is in the form 1 over f of d multiplied by your r of x, or applied on the function r of x. And we will call 1 over fd as the inverse operator. Okay, the first case is when r of x contains e to the ax. So the inverse operator corresponding to e to the ax is 1 over f of t times e to the ax. That's your particular solution. And then if f of a is not equal to 0, then we will replace d by a, that is coming from the coefficient of the exponential function. But if f of a equals 0, okay, we split the function of f of t by two group of factors. The first one is the one that makes the denominator 0, and then the factor that makes the denominator equal to 0, okay, will give you x raised to n over n factorial. And then your g of t, or the other factors, we apply the first rule. So we replace d by a. Let's consider this differential equation. Okay, so for the complementary solution, we replace all d by m. Okay, so we get m squared here, m minus 3 raised to the power 4. This is m plus 1, and then get rid of y here, equals 0. So this is your auxiliary equation. And the roots are, so you have two 0 roots. This is 3, so you have, this is 4 times. The power here is 4, so this is 4 times. And then m plus 1, so the root is negative 1. So this is okay, so this is 4 times. So when you write down your complementary solution, so for 0 you have polynomials up to x, and then for identical roots with multiplicity of 4, so you have 4 arbitrary constants, and then the highest power should be k minus 1. So if we have 4 identical roots here, so the highest power should be x cubed. And then for negative 1, you have constant, and then e to the negative x. So let's have the particular solution. Okay, so the right hand side, we have 20e to the 3x plus 8e to the negative 2x plus 12. Okay, so your y sub p is 1 over f of t. Your f of d is d squared. My d minus 3 to the 4th, d plus 1. Okay, and then we identify your I'll change the color of my to yellow. Okay. So, your A here is equal to 3. Here we have A negative 2. Now, for constants, this is A to the 0x, so we take A to be 0. Okay, so for 20e to the 3x, okay, your A here is 3, so we separate 1 over d minus 3 to the 4th. That will make your denominator equal to 0. And then times, okay, d squared times d plus 1. And then a to the 3x plus this is 8 over, okay, if a is equal to negative 2, so there are no factors that will make the denominator equal to 0. So we put everything here. Okay, so e to the negative 2x. And then the last one, we have 12. Oh, by the way, your a here is 0. So this squared will make the denominator equal to 0. So we separate that from the other factors. Okay. So the constant 12. Okay, so applying the second rule, so the power here is 4, so that gives you x to the 4th. The factor that will make the denominator equal to 0, so that is d minus 3. And then in that case, that gives x to the 4th over 4 factorial. Okay, and then I forgot here the constant 20. So I have here 20, okay, over, so 3 squared times 3 plus 1 times e to the 3x. Okay. Plus, okay, you have 8 e to the negative 2x. Okay, your a here is negative 2, so negative 2 raised to the power 2, negative 2 minus 3 raised to the power 4, and then negative 2 plus 1. Okay, and then for the last one, we have, so this is d squared, so you have x squared over 2 factorial, and then 1 over 0 minus 3, your a here is 0, b to the 4th, then 0 plus 1, and then times the constant. Okay, so simplifying, so this will give you 5 over 216, x to the 4th e to the 3x, okay, e to the negative 2x, and then simplify this, that is negative 2 over 625, and then simplifying this, no, will give you 2 over 27x squared. And then combining your, okay, y sub c, this is your y sub p, so this is your general solution. Okay, let's consider sine and cosine function in R of x. So this is applicable only when your f of d can be expressed as a function of d squared. And so for sine ax, your inverse operator will be Okay. 1 over f of d squared sine e to the ax, and then apply this, copy the function f of negative a squared. So meaning we apply d squared, or we replace d squared by negative a squared, provided that f of negative a squared is not equal to 0. When you have a cosine, so similar to a, but instead of sine, we have cosine here, provided f of negative a squared is not equal to 0. So what happens when f of negative a squared is equal to 0? So, for example, you have 1 over d squared plus a squared. So this is applicable only for a factor, no, that is in the form d squared plus a squared. So we replace sine by cosine and then multiply by negative x over 2a. So a here coming from the coefficient of the sine function. Okay, and then for cosine, you have positive x over 2a. So from cosine, it becomes sine ax. Okay. So let's work on this problem, differential equation. Okay, what is our complementary solution? This is your, okay, your auxiliary equation, m squared plus 16, and then the roots are plus minus 4i. So the complementary solution will be cosine and sine function. No, your a here is equal to 0, so this is pure imaginary, so there will be no exponential function here. Okay, so your r of x, we have 4 e to the 2x, 4 cosine 2x, 7 sine 3x minus 5 sine 4x. Okay, your a here is 2. Here 2 also. Your a here is 3. A here is 4. Okay. So your y sub b therefore is equal to, okay, 1 over, okay, d squared plus 16 times your r of x. Okay. Now you have here a equals 2, so we can substitute. So this is 2 squared plus 16. Okay, so this is more direct. And then multiply by 4. And then for cosine, so a here is 2 also. So okay, your a here, so negative a squared. What is your negative a squared? That is negative 4, no? When a is equal to 2. And then we substitute here. So this is 1 over negative 4 plus 16. And then cosine 2x. Okay, plus 4, 7 sine 3x, your a here is 3. So that will be 7 over, so negative a squared, so negative 3 squared, so that will be negative 9. So you have here negative 9 plus 16, and then sine 3x. Okay. And for the last one, negative a squared, that is negative 4 squared, no? Which is negative 16. And that makes your denominator equal to 0. Okay? And therefore, we apply the second rule. So, now for sine function, that will be negative. Okay, so you have negative 5 here, and then negative x. Okay, you have negative x over 2a. Okay, your a here is 4. And then from sine, we'll make it cosine 4x. Okay, so therefore your y sub p is equal to what is your 4 over 4, so that will be 1 over 5 e to the 2x. Okay, and then here you have 1 over you have 4 here. Okay, so that gives you 1/3. Okay, cosine 2x plus 7 over this. This is 7 over 7, so we have plus sine 3x, and then plus 5 over 8 cosine 4x. So this is your y sub p. Okay, and then you're combining that to y sub c, the complementary solution, you get the general, okay, the general solution. Okay, so what happens when you have x to the n, polynomial in x? So this will be your inverse, okay, your inverse operator. This is the expansion of f of d, which is obtained by dividing 1 by the function d that is in the ascending order. Okay. So we start with the lowest or smallest power of d, and then divide. Okay, so let's work on this problem that involves exponential function. Okay, so let's start with the complementary solution again. So the roots are 0 and 3. That gives you c1 plus c2 e to the 3x. Okay. And then for the inverse operator, so we have 1 over d squared plus 3d. Okay, your a here is 1. Okay. So this just gives us 1 over 1 squared plus 3d. 3 times 1. Okay, 3 times 1. E to the x. Okay. And then plus 1 over d squared plus 3d times 4x squared plus x. So we try to expand 1 over d squared plus 3d. So we divide, okay, 1 by 3d plus d squared. Okay, so 1 over 3d, that will be 1 over 3d. And then multiply, you get 1 over 3d times 3d will give you 1. Plus, this is 1 over 1/3 d. So change the sign. Okay, we'll give you 1/3 d here. And then divide negative 1/3 okay, negative 1/3 d by 3d. Okay, so that gives you negative 1 over 9 here. Okay, then multiply will give you negative 1/3. Okay, minus 1 over 9 d squared. Okay, so change the sign. Okay, and then 1 over 9 d squared, and so on and so forth. So for the expansion, if you continue, this will give you plus 1 over 27d. 1 over 81 d squared, and so on. Okay, so that is actually infinite. Okay, so this is the expansion. Now take note, we'll just consider d squared because the third derivative of x squared will give you 0, no? Because the second derivative will give you constant here, so the next derivative or differentiation will give you 0 for the constant. Okay, so we only consider up to d squared. Okay, so what happens here? So we have 1/4. Okay, we have 1/4 e to the x. Now this one is actually 1/3. When you have 1d, it means integral. So integral, okay, integral of this. So we have 1/4 here, e to the x, okay, plus 1/3, integral of 4x squared is x cubed over 3, and then this one is x squared over 2. So 1 over d is means integral, so single, and then if you have 1 over d squared, you have double integral. Okay, and etc. And then since this is constant, so we just multiply. So negative 4 over 9 and negative 1 over 9 x. This is first derivative, so plus 1 over 27, and then first derivative is 8x, and then derivative of x is 1. And then the other one is negative 1 over 81. Second derivative of this, okay, same as this. So derivative of the 8x plus 1 is a second derivative. So 8 multiplied by 8. Okay, and then derivative of 1, of course, it will be 0. So we only consider up to d squared. The remaining the remaining terms will be 0. So simplifying, yan, 1 over 4 e to the x. And then we combine all x cubed will give you 4 over 9. And then x squared, negative 5 over 18. 5 over 27x. And then for the constant, yan, 1 over 27 minus 8 over 81 is 5 over 81. And then, okay, take note that this is constant, can be combined. Your complementary solution contains C1, that is a constant. So you can combine the two. Okay, so it has to be simplified into only one arbitrary constant. So you can either use another constant. So let's say C sub 3. Okay,